the last section of Chapter 2, 2.4, talks about how do we solve equations with fractions. Okay, so again, just to recap, remember what it is we're trying to do. We're trying to get the x by itself, right? Or y, or whatever letter we end up having. So in these problems here, our first step is going to be to find the common denominator of all the fractions. Okay, so number one, I'm going to write it over here on the side. Let's find the LCD. Number two, we're going to multiply by the LCD. Okay, and then we'll combine like terms and solve. So let's take a look at the first problem. I'm looking at my three denominators, which are 3, 6, and 2. So my common denominator between all of those is going to be 6. Okay? So what I'm going to do now is I'm going to put a big sort of brackets around both of them. And I'm going to multiply everything by 6. But because I have fractions, I want to think of 6 as a fraction. I'll write it as 6 over 1. So we're going to go 1, 2, 3. We're going to go in real slow motion here, okay? So look, 6 times 1, 6 with an x. 6 times 5, 30. 6 times 1 is again 6. Now I'm going to come back and I'm going to multiply the bottom numbers. But the bottom number here is 1. So 1 times 3 is still 3. 1 times 6 is still 6. And 1 times 2 is still 2. Now if we did this right, all of our fractions are going to go away. So 6 divided by 3 gives me a 2x. 30 divided by 6 gives me a 5. 6 divided by 2 leaves me with the number 3. So we can go ahead and minus 5 on both sides. We end up with 2x equals negative 2. So when we divide both sides by 2, I'm coming up with x equals minus 1. Okay? This is going to be our process every single time. Okay, we're going to find the LCD of all the fractions, and then we're going to multiply everything by that common denominator. Let's try to do the same thing for the second problem here. Okay, so between 15, 5, and 3, well, 15 will be our common denominator, right? And we can write it as 15 over 1. So remember, like I said earlier, we're going to go in slow motion. The tops with the tops and the bottoms with the bottoms, right? So 15 times 4, 60 with an x, because there's an x there. 15 times 1 is 15. 15 times 2 is 30 with an x, because there's an x there as well. Okay. Now, remember, the bottom number is getting multiplied by 1. So those numbers will stay the same, right? Because when you multiply by 1, nothing really changes, right? All right. So let's take a look at what we have here. We have 60 divided by 15. That's going to leave me with, let me grab another color, 4x, okay, plus 15 divided by 5 is 3, and 30 divided by 3 is 10x. So remember, I'm going to move my 4x over because I want to get all the x's together. So let's go ahead and minus 4x on both sides. 3 equals, let's see, 10 minus 4 is 6. We can divide both sides by 6. And I just need to reduce that fraction. 3 divided by 6 is the same as 1/2. Okay. Excuse me. Let's try the next one here. So again, first step, between 8, 4, and 4, 8 is going to be our common denominator, right? So remember, I can think of the numbers in front of those x's as 1s if it helps, right? So 8 times 1x is an 8x, plus another 8x, equals a negative 8 times 3, negative 24. Okay. Remember, the bottom numbers are all getting multiplied by 1. That stays an 8, that stays a 4, that stays a 4. Again, if we did this right, our fractions are going to go away. 8 divided by 8 is a 1x. 8 divided by 4 is a 2x. Negative 24 divided by 4 is a negative 6. So 3x equals negative 6. So when we divide both sides by 3, we come up with x equals negative 2, right? Good. All right, let's try the next one here. The first thing I'm going to do, guys, I noticed that 15 isn't a fraction. So let's think about it as a fraction by writing it over 1. Okay. Between 1, 2, and 4, remember our common denominator here is going to be 4, right? So I'm going to write this as 4 over 1. And we're just going to go straight across. So we said 4 times 15 is 60. Minus, because there's a minus there. 4 times a 1x is a 4x. 4 times 1x again is another 4x. The bottoms all stay the same. That stays a 1, that stays a 2, that stays a 4. So now let's see, when we divide out, we have 60 minus 4 divided by 2 is 2x equals 4 divided by 4 is a 1x. Let's go ahead and add 2x to both sides so we can get all the x's together. 60 equals 1x plus 2x is a 3x. We can divide both sides by the number 3. And coming up with x equals 20. Right? Good. Okay. Excuse me. Let's try the second problem on this page. Pardon. So I'm going to think of that as a 1. Think of that as a 1. Let's see. Between 3, 1, 6, and 1, common denominator would be 6. So 6 over 1. Now we're going to multiply this 4 times, right? If it helps, I can think of the number there as a 1x. So 6 times 1x is a 6x. 6 times 3 is an 18. 6 times 5 is a 30 with an x. 6 times 2 is a 12. Okay? Remember, since the bottom numbers are getting multiplied by 1, they stay as they are, right? Okay. So now let's see. We have 6 divided by 3, 2x, plus 18 equals 5x plus 2. Okay, I'm going to move my smaller x to my bigger x. So I'm going to move the smaller x this way. That'll leave me with the 18, because those will cancel. 5 minus 2 is a 3x plus 2. Let's go ahead and minus 2 on both sides. So 18 minus 2 is 16 equals 3x. So when we divide both sides by 3, guys, it won't go in nice and neat, so we'll just leave our answer as 16 over 3, okay? Right. Let's try this next one here. So notice we have y minus 5 all over 4 equals 1 over y minus 5, okay? I think of that as 1 over 1. So we have a 4, a 1, and a 5. Our common denominator here is going to be 20. So 20 over 1. Go once, twice, 3 times. Guys, I'm going to show you something here. Because this whole thing is being divided by 4, I kind of want to think about that sort of like in parentheses. I'm not actually going to distribute it yet, okay? I'm going to leave it as 20 times y minus 5. Okay? 20 times 1 is still 20. 20 times, I can think about that as a negative 1y is a negative 20y. Remember what we said, our bottom numbers should all stay the same. That stays a 4, that stays a 1, that stays a 5. Okay, what I want to do now is we can say 4 goes into 20 5 times, right? So let me go ahead and write this out here. If I divide that, that's still 20. 20 divided by 5 is 4. Okay. I'm going to scroll down. Hopefully I have enough room here. We'll make enough room. Multiply here. 5y minus 5 equals 20 minus 4y. Let me go ahead and add 4y to both sides. Those cancel. 5 and 4, I'm going to write it over here on the side where I have some room, is going to give me a 9y minus 5 equals 20. I can add 5 to both sides. And we get 9y equals 25. And finally, I'll just divide both sides by 9. And I end up with 25 over 9. Okay. There we go. Good. Let's try the same thing for this next problem here, okay? So, between 3, 4, and 12, 12 is going to be our common denominator. So again, I'm going to put that 12 in front here with my x minus 2 equals at 12x plus 12 times 5 should give us 60. Okay. Remember, my bottom numbers stay the same. So again, just like we did earlier, 3 goes into 12 4 times. I'll write my 4 with my x minus 2 right here. Those cancel. There's my x. 4 goes into 16, or 60, I'm sorry, 15 times. Now we can go ahead and distribute our 4. 4x minus 8 equals x plus 15. Let me go ahead and subtract x on both sides. Okay. That gives me a 3x minus 8 equals a 15. And we can go ahead and add 8 to both sides. 3x equals, let's see, 15 and 8 should give me something like 23. And when I divide both sides by 3, it doesn't go in nice and neat. So again, I'm just going to leave my answer 23 over 3, right? There you go. All right. So let's take a look at the next one here that has all the decimals, right? Let's see, remember my first step, bring this down. Let's go ahead and add 5.1 to both sides. Okay. So I end up with a negative 3.2x equals, let me grab my calculator. Here it is. So 2.9 plus 5.18. It is 8. Oops. Then we can divide both sides by a negative 3.2. Okay. And if I take my calculator again, 8 divided by 3, 3.2 negative equals negative 2.5, right? Boom. And we got it. Good. All right. So let's take a look at this next problem that we got here. Again, guys, first thing I'll do, draw my line down. And I want to see if we can combine any like terms. So look, that's a 1x. 1x and 3x, 4x, 4x plus another 3, 7x minus 2, right? Equals negative 11 plus, let's go ahead and take that 7 and distribute it to both pieces. We're going to have a 7x plus a 14, right? And so now, let's go ahead and see if we can combine anything on the right side. So I'll leave my 7x alone. Let's see, a negative 11 and a plus 14 should give me a plus 3. Okay. Now typically we've been saying, let's move the smaller x to the bigger x. But if you notice, they're both 7s. But if we were just to subtract 7x on both sides, that 7x and that 7x would cancel. That would leave me with the number negative 2. This 7x and this 7x would also cancel, and that would leave me with the number 3. And look at the equation we have. The equation we have is negative 2 equals 3. But we know that those two numbers aren't equal. So what we have here, guys, is there is no solution, right? So it's kind of like when you're a little kid and you got to walk all the way down 2 or 3 blocks to your friend's house, and then you knock and there's nobody there. and then you got to walk all the way back. So we did all this work just to say there's no solution, right? So let me tell you, when is there no solution? If the x's cancel out and we get something like this that doesn't make sense, no solution, right? Let's try the next one. Let's see what we can figure out here. Okay, grab my pen again. I draw the line going straight down. Just let me know that I have the two sides. Let's multiply our 7 on both sides. 7x. 7 times 4 is 28 minus 10 equals, let's combine like terms here. Let's see, 3x and 4x is also 7x. Okay, 20 minus 2 should give me an 18. Okay. So now we have 7x over here. 28 minus 10 is 18 equals 7x plus 18. Okay. If we subtract 7x on both sides, this 7x and that 7x would cancel out. We'd end up with an 18. And those would cancel. We'd also end up with an 18. Now, I'm going to show you this is a little bit different. The x is canceled out, but we have something that makes sense, like 18 equals 18. When this happens, we say the answer here is going to be all real numbers. Okay? Because even though our x is canceled, we ended up with a statement that is true, like 18 equals 18, right? All right. Let's see what we can do with this next problem here. I'm going to draw my line coming down. So my 11x minus 8 stays as it is. Remember, I'm distributing the number negative 4. It's a negative 4x minus 12. Let's see, plus 4. Okay. And so now we have 11x minus 8 equals negative 4x minus 12 plus 4 is a minus 8. Okay. Let me go ahead and add 4x to both sides. So now I have a 15x minus 8 equals negative 8. When I add 8 to both sides of the equation, we get 15x equals 0. Divide both sides by 15. And 15 divided by 0 is still 0, right? Good. Okay. And this looks like it's our last problem. All right. Let's take a look. Let's put a line all the way down. Let's multiply our 5. Negative 15 plus 20x. Let's multiply the 4. Let's see. 4 times 2 is 8x plus 4. Oops, not plus 4. That was my mistake right there, guys. Plus 4 times 4 is 16 plus 12x. Okay. So on the left side, still got negative 15 plus 20x equals. Here we can combine. 8 and 12 is going to give us 20x plus 16. Okay. We can go ahead and subtract 20x on both sides. Those would cancel. And I'd end up with a negative 15 equals 16, which we know is not true. So remember, when it's not true, it's no solution, right? And that was section 2.4.